There is something about a hummingbird that feels almost like a rumor, like something the world invented in a quiet moment, just to see if anyone would notice. Welcome to Sleepy Science. Tonight we are going to spend some time with one of the smallest, most quietly extraordinary creatures that has ever existed on this earth. If you enjoy the channel, a like and a subscription mean more than you know. And if you want to leave a comment telling us what topic you would love to drift off to next, we read every single one. And if you ever feel like supporting Sleepy Science so we can keep making these videos, there is a Patreon, just a small, quiet corner of the internet where that is possible. But for now, settle in. Let your shoulders drop. And let's begin. Somewhere in a garden or beside a window you have probably passed 100 times, there is a hummingbird. You may not see it at first. It is small enough to disappear behind a single flower. But if you stay still long enough, if you let the day get quiet around you, it will appear. And when it does, there will be a sound, a low, soft hum that seems to come from the air itself rather than any living thing. That sound is the reason for the name. The hum of a hummingbird is not made by its voice. It is made by its wings. Dozens and dozens of beats every single second, so fast that the wings become invisible, and all that remains is that low, velvet vibration, hanging in the air around it. Most birds beat their wings somewhere between 1 and 20 times per second. The hummingbird, depending on the species, beats its wings between 10 and 80 times per second. The smaller the species, the faster the wings. The bee hummingbird, the tiniest bird on Earth, can beat its wings nearly 80 times every second. 80 times in a single second. That number is so large and so fast that the human eye cannot follow it. The wings simply vanish. They become a soft blur, a haze, a suggestion of movement where something solid used to be. And yet the bird itself is completely still, hovering, suspended in place, as though gravity forgot about it for a moment. That hovering is one of the most quietly remarkable things a bird can do. Almost no other bird in the world can truly hover. Some can hang in the wind, letting the air do the work. But the hummingbird hovers, in completely still air, in dead calm, in the middle of a windless afternoon, as though it has simply decided that the usual rules do not apply to it. It achieves this by doing something no other bird does. It rotates its wings in a figure-8 pattern. Most birds generate lift only on the downstroke, the push down through the air that sends them upward. The hummingbird generates lift on both the downstroke and the upstroke. Forward and back, over and under, a continuous looping motion that keeps it locked in place, with a precision that would take an engineer years to replicate. Engineers have, in fact, tried. Robotics researchers have spent decades attempting to build machines that can do what a hummingbird does effortlessly. The challenge is not just the speed. It is the control. A hummingbird can stop on a single point in space and hold that point, with an accuracy of a few millimeters, adjusting dozens of times per second, to wind, to air pressure, to the slight sway of the flower in front of it. It can do this while reaching its beak into the exact center of a blossom, without touching the petals. Without touching the petals. That is a level of delicacy that is very hard to hold in your mind when you think about how fast everything is happening. Let's slow down for a moment and think about what the world looks like from inside that speed. A hummingbird's heart beats somewhere around 1,200 times per minute while it is flying. 1,200. Your heart, right now, is probably beating somewhere between 60 and 100 times per minute. The hummingbird's heart beats 20 times faster than yours, and its lungs breathe in and out about 250 times per minute. Every function in its body is dialed to an almost unimaginable intensity, just to keep those wings moving. When you see a hummingbird perched on a branch, looking calm and still, its heart is still beating around 250 times per minute. Even at rest, it is running faster than most of us ever do. And yet there is a quiet to them. Have you ever watched a hummingbird feed? Not the wings, the bird itself? Its body is so still. Its head is so precise. There is a kind of concentration in the way it drinks that looks almost meditative. As though inside all that speed, there is a stillness at the center, a calm eye in the middle of the storm. Maybe that is not so different from how you feel sometimes. Everything moving very fast around you, and somewhere inside, a part of you just watching, very still, very quiet. Hummingbirds exist only in the Americas. This is easy to overlook, but worth pausing on. Every single hummingbird species, and there are more than 350 of them, lives in North, Central, or South America. Nowhere else in the world. If you live in Europe, or Asia, or Africa, or Australia, you have never seen a wild hummingbird. The first Europeans to encounter them must have been completely at a loss for what to call them. Some early descriptions compared them to jewels. Some compared them to large insects. Some could not believe they were birds at all, because nothing in European nature had prepared anyone for something that small, that could fly that way. The word hummingbird itself is just a description of the sound they make. Whoever first named them simply said what they heard, a hum, and the name stuck. In many indigenous cultures across the Americas, the hummingbird has carried deep meaning for a very long time. In some traditions, it is a messenger between the living and the dead. In others, it is a symbol of joy, or of love, or of persistence. The Aztecs believed that warriors who fell in battle would be reborn as hummingbirds. There is something beautiful in that idea, that after all the heaviness of a life, you might return as something almost impossibly light something that hovers, something that drinks from flowers, something that catches the light and turns it into color. Speaking of color, the colors of a hummingbird are not quite what you might think they are. You have probably seen that flash of green, or that sudden blaze of red or purple or gold as one passes through a garden. It looks like the feathers themselves are colored, but they are not. Not exactly. The iridescent feathers of a hummingbird work the same way a soap bubble does. The color you see is not pigment. It is light. The feathers are built from microscopic structures, tiny platelets, arranged in layers, like a stack of very thin glass. And when light hits those layers, it bounces and interferes with itself and produces a color. The color changes depending on the angle. This is why a hummingbird's throat can look jet black in one moment and then suddenly blaze ruby red as the bird turns its head. The color is real, but it lives in the light, not in the feather itself. Move the light and the bird changes, which means, in a way, that every hummingbird looks different, depending on where you are standing. This quality, the way the color lives in light rather than matter, is called iridescence. And it is shared by some other creatures, certain beetles, certain butterflies, mother of pearl inside a shell. But in hummingbirds, it reaches a particular intensity. The male ruby-throated hummingbird, the one most people in North America know best, has a throat that can look like a burning coal or like dried blood, depending on the light and the angle. And the females, often described as dull by comparison, have their own subtle iridescence, a quiet green sheen that catches the sun in surprising ways, if you are patient enough to look. Most of the time we only notice the dramatic, but the subtle is always there. The smallest hummingbird is also the smallest bird on Earth. The bee hummingbird, which lives in Cuba, is about 5 centimeters long, roughly the length of your middle finger. It weighs less than 2 grams. Less than 2 grams. That is lighter than a single penny. Lighter than a small paperclip. Lighter than a dime and a nickel stacked together. And yet, it is a complete bird, with a heart and lungs and a brain and eyes that can see colors you cannot, and a voice that sings, and a life that has meaning and purpose in its own small, beautiful terms. On the other end of the scale, the largest hummingbird is the giant hummingbird of the Andes, which can reach about 21 centimeters in length and weigh around 20 grams. 20 grams, still lighter than a slice of bread. But for a hummingbird, it is enormous. The giant hummingbird beats its wings more slowly than its smaller relatives, only about 8 to 10 times per second. Slow enough, almost, that you might just barely see the wing beat, if the light is right. It lives in the Andes Mountains of South America, at altitudes where the air is thin and the flowers are few, and it migrates seasonally to find enough nectar to survive. That migration, a large-bodied hummingbird traveling alone through mountain passes, is one of those images that is easy to overlook, but quietly extraordinary. Hummingbirds eat an enormous amount, relative to their size. To power those wings, that heart, that impossibly fast metabolism, a hummingbird must consume roughly half its body weight in nectar every single day. Half its body weight in nectar every day. If a human being had the metabolism of a hummingbird, they would need to eat hundreds of thousands of calories a day just to stay alive. The hummingbird manages this by visiting hundreds of flowers, sometimes over 1,000, in a single day. It moves through a garden or a forest in a precise and methodical way, visiting each flower in a particular order, remembering which ones it has already drained and which ones have had time to refill. A hummingbird has a memory for flowers. It tracks them. It plans. This kind of memory and spatial planning is one of the things that makes hummingbirds remarkable beyond their wings. For their body size, hummingbirds have the largest brains of any bird. About 4.5% of their total body weight is brain. By comparison, the human brain makes up about 2% of our body weight. That large brain, relative to body size, is what allows the hummingbird to do what it does. Not just the flying, the remembering, the planning, the recognition of individual flowers, individual feeders, individual human beings. Yes, hummingbirds can recognize individual people. They learn faces. They learn routines. They know when you usually go out to fill the feeder, and some of them will wait for you. There are stories, and these are real, not legend, of hummingbirds that return to the same garden, to the same porch, to the same feeder, for years in a row. The same individual bird, returning to the same person. Ornithologists have confirmed this through banding studies, placing tiny, nearly weightless bands on a bird's leg, and then tracking it over time. A banded female ruby-throated hummingbird was recorded returning to the same backyard in the eastern United States for 9 consecutive years. 9 years. She crossed the Gulf of Mexico twice every year, a journey of over 900 kilometers, and came back to the same yard, the same flowers, possibly the same person on the porch. That crossing of the Gulf of Mexico is one of those facts that deserves a long, quiet moment to sit with. The ruby-throated hummingbird, which weighs about 3 grams, flies non-stop across the Gulf of Mexico. During its migration, that is roughly 900 kilometers of open water. No land, no flowers, no rest. The bird flies for approximately 18 to 22 hours straight, without stopping, without eating, without sleeping. It does this by spending the weeks before the migration, eating constantly, doubling its body weight in fat reserves. It arrives on the other side, leaner, quieter, and immediately begins looking for food. a 3-gram bird, 900 kilometers, non-stop. It does this alone. Unlike many migrating birds, hummingbirds do not migrate in flocks. Each bird travels by itself. No group to shelter with, no companions reading the wind. The young of the year, hatched in summer and never having made the journey before, somehow know to go. They know which direction. They know roughly when. Scientists believe they carry a kind of inherited map, not learned from their parents, because they often migrate after the adults have already left, but built into them somehow, deep in the biology. A first-year hummingbird crosses the Gulf of Mexico alone, on a map it was born with, but has never had to use before. The hummingbird's tongue is worth spending some time with. It is long, much longer than you would expect, often extending beyond the beak by a centimeter or more. For a long time, scientists assumed it worked like a straw, capillary action drawing the nectar up through the tubular tongue. But slow-motion video, taken in the last few decades, showed something different. The tongue is forked at the tip, and the two sides of the fork open and close as they move through the nectar, like two tiny hands scooping, folding, and trapping liquid with each stroke. The hummingbird laps nectar the way a cat laps water, only about 13 times per second. 13 times per second. That tongue is moving so fast, it is invisible. And with each lap, it traps a precise micro-drop of nectar and carries it down into the throat. The beak of a hummingbird is equally extraordinary. Each species has a beak shaped for a particular kind of flower. The sword-billed hummingbird of South America has a beak longer than its own body, the only bird on Earth with that distinction. It can reach 6 or 7 centimeters. The bird uses it to feed from flowers with long, narrow tubes, flowers that no other hummingbird can access. This is a relationship that evolved over millions of years. The flower grew longer, and the beak grew longer in response, or vice versa. It is hard to know who led and who followed. They fit together now like a key and a lock that were shaped for each other across enormous stretches of time. Other species have curved beaks, some curving downward to fit the arc of a heliconia bloom, some curving upward slightly to match a flower that tips its face toward the sky. Each one is a conversation, written in the shape of a beak and the shape of a petal, between a bird and a plant that have been talking to each other for longer than our species has existed. This is one of those things that the more you look at, the more it opens out into something very large and very old. Hummingbirds are important pollinators, perhaps not as famous in that role as bees, but no less vital. As a hummingbird pushes its beak into a flower to drink, pollen collects on its head and beak and throat. It carries this pollen to the next flower, and the next, and the next, fertilizing plants as it goes, linking one flower to another, across an entire meadow or forest. Some flowers in the Americas can only be pollinated by hummingbirds. If the hummingbird disappeared, those plants would disappear with it. And if those plants disappeared, the insects that depend on them, the animals that eat those insects, the larger animals that depend on those smaller ones, all of it would shift. A single small bird, 3 grams, hovering in a garden, holds threads that reach through the entire web of life, in the places where it lives. This is one of the quieter truths about hummingbirds, that they are not ornaments. They are not there to be beautiful, though they are. They are workers. They are links in a chain that took millions of years to build. The garden is not a backdrop for the hummingbird. The hummingbird is part of the garden's actual functioning, one of the mechanisms that makes growth and bloom and seed and next year's flowers possible. Remove the bird and you change the garden in ways that take decades to fully understand. Most hummingbirds are solitary. They do not flock. They do not nest together. They do not, for the most part, travel in pairs or groups. Even the breeding season is brief and businesslike. A male will perform an elaborate display, diving, arcing, flashing his gorget in the light. And if a female is impressed, they will mate, and then he will leave. The female does everything alone after that. She builds the nest. She incubates the eggs. She feeds the chicks. She raises them to the point of independence, and then they scatter, and she is alone again. There is something in that image, a small bird alone in a world of flowers, that is neither sad nor heroic, just very quietly real. The nest of a hummingbird is one of the most beautiful constructions in the natural world. It is small, barely the size of a walnut shell for many species. The female builds it from plant down, from soft fibers, from the silk of spiders' webs. She collects spider silk deliberately, weaving it into the structure, not just as a binding agent, but because spider silk is elastic, it stretches. As the eggs hatch and the chicks grow, the nest stretches with them. The same nest that held 2 eggs the size of small jelly beans will expand gently outward to hold 2 growing birds until they are ready to fly. She built it to grow. She thought ahead. Or rather, evolution thought ahead for her, across thousands and thousands of generations, until the knowledge of how to build a stretchy nest from spider silk became part of what a hummingbird is. The eggs are tiny. 2, usually, about the size of a coffee bean or a large pea. Pure white. The mother incubates them for about 2 weeks, sitting on them alone. Her small, warm body wrapped around these 2 small white ovals in a nest no bigger than a thimble. When they hatch, the chicks are blind and featherless. They are vulnerable in a way that is almost hard to picture. A creature weighing less than a gram, utterly helpless, alive in a world that is very large and very cold. Their mother feeds them by regurgitation, inserting her beak into their open mouths and pumping nectar and tiny insects directly into their stomachs. She does this dozens of times a day, going out to forage and returning again and again until they are ready for the world. Yes, insects. This is something that surprises people. Hummingbirds are not purely nectar drinkers. They eat insects too. Nectar is fuel, sugar for energy. But protein comes from insects. Tiny gnats, small spiders, aphids, midges. Hummingbirds catch these in the air or pick them off leaves with the precision of a very small, very fast pair of tweezers. During nesting season, when the chicks need protein to build feathers and muscles and bones, a mother hummingbird's diet shifts toward more insects than usual. She is not just a flower drinker. She is a hunter, a quiet, hovering, iridescent hunter, moving through the garden like a whisper. Hummingbirds are also, and this might surprise you, quite aggressive. For creatures so small and so beautiful, they are remarkably territorial. A single hummingbird will defend a patch of flowers or a feeder against all comers, including birds much larger than itself. It will dive at intruders. It will chase them. It will sit in a high, visible spot, a dead branch, a fence post, and keep watch over its territory with the focus of a sentinel. This is not aggression for its own sake. It is survival. The flowers in that territory are the food that keeps the bird alive. Defending them is defending life itself. And so the most delicate-seeming creature in the garden is often the most ferocious defender of its small piece of the world. Hummingbirds can fly backward. This is another thing almost no other bird can do. That figure-8 wing rotation that allows hovering also allows the hummingbird to move in any direction, forward, backward, sideways, straight up, straight down. It can flip upside down in flight, rolling to avoid a predator, or to access a flower growing on the underside of a branch. In laboratory tests, hummingbirds have been filmed flying through gaps in barriers, so small that the bird had to fold one wing partially and twist its body sideways to fit. It did this without slowing down, without hesitation. The control over its body in three-dimensional space is something we are still learning to fully understand. Their feet are small and weak relative to their body. Unlike most birds, hummingbirds cannot walk. Their legs are short and their feet are not built for walking. They can perch, and they do, often, because perching uses far less energy than flying. But on the ground, they would be helpless. They shuffle sideways on a branch by using their feet to grip and reposition, but that is the extent of it. Everything important in a hummingbird's life happens in the air. They are built for that and nothing else, so completely that the abilities we take for granted, walking, running, standing on flat ground, are simply not part of what they are. Each evening, a hummingbird faces a problem. It has burned through an enormous amount of fuel during the day. The night is long and cold. There are no flowers to visit, and the bird's metabolism, if it continued at its daytime rate, would exhaust its reserves before morning. It would starve in its sleep. So the hummingbird does something remarkable. It drops into a state called torpor. Torpor is not exactly sleep. It is something deeper, something closer to what a bear does in winter, but compressed into a single night, and done with far greater urgency. In torpor, the hummingbird's heart rate drops from 1,200 beats per minute to as few as 50. Its body temperature drops close to the surrounding air temperature. Its breathing slows almost to nothing. It becomes, to all appearances, something very close to dead. There is a reason this matters. The torpor state reduces the hummingbird's energy use by about 90%. 90%. Instead of burning through all its reserves overnight, it uses only 1/10 of what it would otherwise need. And then, as dawn approaches, it warms itself back up, using shivering and its own metabolic heat, and gradually comes back to full speed. This process takes 20 to 60 minutes. A hummingbird waking from torpor looks like it is waking from death. It trembles. It is slow. Its eyes are glassy. And then, gradually, the world returns. The heart accelerates. The wings flex. The eyes sharpen. And the bird returns to being, entirely and suddenly, itself. There is something in that. The daily journey, from full living to near stillness and back, that is very calming to think about. A hummingbird does not fight the quiet of the night. It gives itself to it completely. It trusts the body to manage what the mind cannot consciously oversee. Every night, without anxiety, it lets go of the pace of the day and sinks into something very like peace. And every morning, without fail, it comes back. Maybe that is something worth carrying with you tonight. The idea that stillness is not the end of something. It is a way of surviving. A way of making tomorrow possible. The hummingbird does not rest reluctantly. It rests completely. Hummingbirds have extraordinary eyesight. They can see colors that you cannot. Human eyes have 3 types of color receptors, for red, green, and blue. Everything we see is built from combinations of those 3. Hummingbirds have 4 types of color receptors. That 4th type is sensitive to ultraviolet light, light that exists just beyond the edge of what we can perceive. To a hummingbird, the world has colors that have no names in any human language. Flowers that look plain yellow or white to us may have vivid ultraviolet patterns, visible only to the bird. Landing strips, guides, arrows pointing toward the nectar. The flower is speaking to the hummingbird in a language we cannot hear or see, and the hummingbird reads it perfectly. Their hearing is sharp too. Though hummingbirds do not communicate through song, the way a robin or a sparrow does. Most of their vocalizations are simple: chirps, chirps, chatters. But they use these sounds precisely for territory, for alarm, for courtship. And some species produce sounds with their feathers during their display dives, feathers modified to create specific tones as air passes through them. The Amaze hummingbird, common on the west coast of North America, produces a sharp, high-pitched trill during its dive, not with its throat, but with two specially shaped tail feathers that vibrate as the bird falls. It is a sound made entirely by speed and feather shape, a song written in aerodynamics, rather than the voice. The Amaze hummingbird is one of the few species that does not migrate. It lives year-round along the Pacific coast, from Baja California up into British Columbia, surviving mild winters that would be fatal for many of its relatives. It was once confined to the Baja Peninsula, but its range has expanded dramatically over the last century, as people planted gardens and put up feeders. The Amaze hummingbird followed the flowers north. Or rather, it followed the people who brought the flowers north. There is a small, quiet lesson there about how what we do shapes what survives and what disappears. Hummingbirds are not found in Europe, but Europe has hummingbird moths. These are insects, true moths, that evolve to look and behave almost exactly like hummingbirds. They hover. They drink nectar from flowers with a long tongue. They are roughly the size of a small hummingbird. They move with the same hovering stability. They have been mistaken for hummingbirds many times by people traveling in Europe who expected the moth and thought they were seeing a bird. This is what biologists call convergent evolution. Two entirely different lineages, separated by an ocean, arriving at the same solution to the same problem. The problem is, how do you drink from a flower without landing on it? The answer, discovered independently by both a South American bird and a European moth, is hover. This parallel, the hummingbird on one side of the world, the hummingbird moth on the other, is one of nature's quiet arguments. That some solutions are so good, so elegant, that life finds them more than once. The universe, in a way, keeps discovering hovering. It keeps coming back to that particular answer, as if hovering is one of the things the world especially wanted to exist. Fossil evidence for hummingbirds is thin and fragmentary. Small bones do not preserve well, but scientists have found fossilized hummingbird-like birds in Europe that date back over 30 million years. These were not the same as modern hummingbirds. They were an earlier group, now extinct, that may have been related ancestors or early cousins. The hummingbirds we know today appear to have split from their nearest relatives somewhere between 40 and 42 million years ago. 42 million years. The continents were in different places then. The climate was different. The flowers were different. The hummingbird began then, in a world so ancient, We can barely imagine it. And it kept going, kept refining, kept becoming more itself, until it arrived here, in this evening, in this moment, as the quiet, hovering, iridescent thing we know. There is currently a hummingbird sitting somewhere in the Americas. Right now, while you are listening to this, it is perched on a branch, perhaps, with its feet wrapped around a thin twig, its heart still beating fast but steadily, its feathers fluffed slightly against the night air. Or maybe it is in torpor, temperature low, heartbeat slow, body still as a stone in the dark. Both of those images are available to you right now. Somewhere in a tree, in a garden, in a forest, one of these ancient, astonishing, tiny creatures is resting, giving itself to the night, trusting, still. Let's talk about species for a moment. 366 hummingbird species have been formally described and named. New species are still occasionally discovered, usually in remote parts of the Andes or the Amazon basin, where scientists are still working through what exactly lives there. The richest region for hummingbird diversity is the equatorial belt of South America. Ecuador, Colombia, Peru, Bolivia, where the meeting of high mountains, deep valleys, and dense tropical forests creates an enormous variety of habitats, and, with them, an enormous variety of birds. Ecuador alone has been recorded as home to over 160 hummingbird species, nearly half of all species on Earth, in a country about the size of the United Kingdom. If you stood in the right cloud forest in Ecuador, on a clear morning, you might see a dozen different species in a single hour. The names of hummingbird species are some of the most beautiful in all of ornithology. Violet-tailed sylph, booted racquet-tail, spangled coquette, rainbow star-frontlet, glittering-bellied emerald, long-tailed wood nymph, sword-billed, as we mentioned, shining sunbeam, fiery topaz. Each name is its own small poem, an attempt by a scientist to capture in words a thing that kept eluding ordinary language. Someone, somewhere, was so struck by the iridescent belly of a bird in a South American cloud forest that they called it the glittering-bellied emerald, and that name has stayed ever since. The marvelous spatule tail deserves its own moment. It is found only in a small area of northern Peru. The male has 4 tail feathers. 2 are short and ordinary. 2 are extraordinary. They extend far beyond the body of the bird, longer than the bird itself, and end in flat, disc-shaped rackets of brilliant violet blue. During his courtship display, the male crosses these 2 long feathers in front of his body, waves the rackets, and swings them independently, creating an effect that looks almost mechanical, like 2 tiny flags, being waved by 2 tiny hands. The female watches from a branch, She is small and brown and utterly practical. He is doing something that seems to belong more to a dream than to a bird. And she watches and considers. The marvelous spatuled tail is critically endangered. Its small range has been shrunk further by deforestation, and only a few thousand individuals remain. Conservation efforts are underway. Local communities have been working to protect the remaining habitat, and ecotourism has given the bird economic value that protects it from land clearing. People come from around the world to stand in a small patch of Peruvian cloud forest and watch this bird display. It is one of those situations where a creature's beauty has become part of its survival strategy. Beauty, in the right circumstances, is a form of protection. Hummingbirds have a very short life expectancy. For the most part, the small species, the ruby-throated, the rufous, the calliope, typically live between 3 and 5 years in the wild. Some live less. The first year is the hardest. Many young birds do not survive their first winter or their first migration. The physics are simply unforgiving. A body that small, burning that much energy, cannot afford many mistakes. But some individuals surprise us. The record for hummingbird longevity in the wild belongs to a female broad-tailed hummingbird that was banded in Colorado and recaptured at the same site. 12 years later. 12 years. In a bird that might weigh 3 grams, living in the mountains of Colorado, crossing the continent twice a year. 12 years. There are trees in that mountain range that were young when she was born and still stand today. In captivity, hummingbirds can live somewhat longer, up to about 10 years on average, with a few individuals reaching 14 or 15. This tells us something. The wild is not a gentle place. The risks are real. A hawk, a cold night with not enough fuel stored, a feeder that runs dry at the wrong moment, a window. Windows are a significant source of hummingbird death. Glass that reflects the sky or the garden, invisible until it is too late. In North America alone, hundreds of millions of birds die each year from window strikes. Hummingbirds, flying fast in pursuit of a flower or a rival, are not immune. This is something that can be changed. Window films and exterior screens make a real difference. A small adjustment to a window can save a bird that was 42 million years in the making. The rufous hummingbird makes one of the longest migrations of any hummingbird. It breeds as far north as Alaska and western Canada, among the northernmost breeding ranges of any hummingbird species, and winters along the Pacific coast of Mexico. Its round trip can cover over 10,000 kilometers. 10,000 kilometers. For a bird that weighs 3 to 4 grams, the proportional distance, relative to the animal's body size, is one of the largest of any migratory animal on Earth. If you scaled the rufous hummingbird up to human size, and kept the proportions of the migration the same, the equivalent journey would be roughly several times around the Earth. All of this from a body the size of a thumb. The rufous hummingbird is also known for its fierce temperament. It is widely considered the most aggressive hummingbird in North America. Rufous individuals have been observed chasing off birds many times their size, including hawks. Not large hawks, but hawks. A bird that could swallow it whole, chased away by a hummingbird. The rufous seems to have decided that its small size is simply not relevant to the conversation. It behaves as though it is the largest bird in any garden, and in practice, many larger birds agree with it. Hummingbirds sleep perched on branches. Like most birds, they choose sheltered spots, inside dense shrubs, underneath large leaves, in the interior of a tree canopy, to avoid the wind and to stay hidden from predators in the dark. While in torpor, they sometimes hang upside down. A hummingbird, dead to the world, hanging by its feet from a twig in the dark. You can touch them in torpor, and they will not respond. This has alarmed many well-meaning people, who found what they thought was a dead hummingbird, and were relieved, half an hour later, to find it awake and gone. The hummingbird was not dead. It was just, completely, absolutely, asleep. What is it like to be completely, absolutely asleep? Not restless, not half awake, not listening for something, but genuinely sunk in, the way a hummingbird is sunk in, with its temperature dropping and its heart barely moving, and all the speed of the day, completely still. There is a generosity in that kind of sleep, a surrender, a trust. Tonight, let yourself be that kind of still. The Amaze hummingbird begins its courtship in December and January, making it one of the earliest breeding birds in North America. While most birds are huddled through the cold, the Amaze male is already displaying, climbing high into the winter sky, and diving. The dive, the famous dive, can reach speeds of nearly 90 kilometers per hour. That is the speed of a car on a highway. Reached by a bird the size of your fist, falling through the sky above a winter garden, creating a sound with its tail feathers at the bottom of the arc that is meant to impress a female, watching from below. What the female makes of all this, we can only imagine. But she has been evaluating these dives for as long as Anna's hummingbirds have existed, which is a very long time. She knows exactly what a good dive looks like. She has seen thousands of years of them, written into her instincts. The calliope hummingbird is the smallest bird that breeds in the United States and Canada. It weighs about 2.5 grams. It breeds in montane meadows, high-altitude flower fields in the Mountain West, and winters in Mexico. For its size, its migration is proportionally enormous, and its ability to survive at altitude, in cold, in thin air, is one of those feats of biology that is quietly extraordinary. It sits in a mountain meadow at 2,000 or 3,000 meters, where the air is thin and the mornings are cold, and it buzzes from flower to flower in the high summer light, like something from a painting. The meadow is temporary. Snow will cover it in a few months, but the bird is there now, fully present, fully alive, drinking every flower in reach. Hummingbirds have a keen sense of time. They remember not just where flowers are, but when those flowers will refill. Different flower species take different amounts of time to produce new nectar after being drained. Some take as little as 15 minutes. Some take several hours. The hummingbird builds an internal map, not just of space. This flower is here, and that flower is there, but of time. It knows, approximately, how long ago it drained each flower, and therefore which ones are likely ready. This is called episodic memory. The ability to remember not just a fact, but the specific circumstances of when and where that fact was learned. It was long thought to be a uniquely human ability. The hummingbird has it. A 3-gram bird, navigating time and space simultaneously, mapping the world around it with a precision that took us a while to notice. Some hummingbirds practice what researchers call traplining. This is the behavior of following a fixed, established route through a territory, visiting the same flowers in roughly the same order at roughly the same time each day. Like a trapline set by a trapper, the route is checked in sequence, and each station yields its small reward. The hummingbird sets its own trapline, adjusting it over time, as flowers bloom and fade, as seasons shift, as competitors move in or out. It is not random. It is not impulsive. It is a plan, carried in a brain the size of a pea, in a skull the size of a grape, in a body the weight of a folded letter. Some flowers have evolved to rely exclusively on hummingbirds. These are called ornithophilous flowers, flowers pollinated by birds. They tend to share certain features. They are often red or orange, colors that hummingbirds are especially sensitive to, and that many insects cannot see as well. They tend to be tubular in shape, fitted for a beak rather than a landing pad, and they tend to produce large quantities of nectar to reward the large-bodied visitors that they need. Red flowers, tube-shaped, full of nectar. Once you know what to look for, you start to see them everywhere. Columbines, salvias, cardinal flowers, coral honeysuckle, each one a message written in color and form, addressed specifically to a hummingbird and to no one else. Hummingbirds, in turn, have evolved to be especially attracted to red. Not because red is inherently better, but because red is where the reward has most reliably been. This preference is not absolute. Hummingbirds will visit orange, pink, purple, and even white flowers if the nectar is there. But red is a strong signal. A shortcut. A color that says, to a hummingbird. Worth checking. This is why red hummingbird feeders have become standard. The red color attracts the bird's attention and draws it closer. The nectar keeps it coming back. You do not need to dye the water red. That dye may not be good for the bird. Just the feeder itself is enough. The color does the work. The flower has been saying this for millions of years. There are around 17 species of hummingbird in the United States. The most widespread and commonly seen is the ruby-throated hummingbird in the east, the only species that breeds east of the Mississippi, and a cluster of species in the west, including the rufous, the broad-tailed, the black-chinned, the calliope, and the anise. In the southeast and southwest, there are others: the Allens, the Costas, the Lucifer. Lucifer hummingbird, another of those names that makes you pause. It comes from the Latin word for light bearer, not from any darker association. The bird was named for the iridescent purple of its gorget, which seems to hold its own light within it. A name about brightness, about something that carries its own illumination. The hummingbird's role in culture extends beyond the Americas. Ever since European explorers brought specimens back to the Old World, hummingbirds have fascinated people who would never see a live one. In Victorian England, hummingbird feathers were used in jewelry and hat decoration. Thousands of skins were imported annually, a trade that was genuinely devastating to populations in certain regions. The birds were killed for their iridescence, which could be mounted in brooches and pins that caught the light and flickered, as though still alive. Those brooches were beautiful. They were also a mass casualty event, carried out in the name of fashion, at the intersection of vanity and commerce, and the belief that the natural world existed, primarily for human use. It is easy to judge from here. It is also worth remembering that we are still making versions of the same mistake in different forms every day. The end of the Victorian feather trade came in large part because of women. Women who refused to wear feathered hats. Women who organized and persuaded and eventually helped push through laws that protected birds from commercial killing. The Migratory Bird Treaty Act in the United States, passed in 1918, was a direct result of this movement. It remains one of the oldest and most effective wildlife protection laws in American history. And it began with people who looked at a hat decorated with dead birds and said, quietly but firmly, "No." Sometimes that is how the world changes. Not with a dramatic gesture, but with a refusal. A small, quiet, firm refusal. Hummingbirds in the wild spend a great deal of time doing nothing. This is easy to overlook, because the moments of hovering and feeding are so vivid. But between those moments, hummingbirds perch. They rest. They preen their feathers, running the beak through each one methodically, realigning the tiny barbs that hold the feather's structure together. A hummingbird spends about 75 to 80% of its day perched. 75 to 80%. All that impossible speed and color and hovering. It happens in the remaining 20 or 25% of the day. Most of the hummingbird's life is spent sitting very still on a branch, watching, resting, being. We tend to define them by the extraordinary moments, but most of their lives happen in the quiet. Maybe that is true of us too. The moments we are seen, the hovering, the brilliant flash of color, they are real and they are part of us. But most of life happens in the sitting still, in the perching, in the watching from a high branch. And that part is not less than the other part. It is where the energy is gathered. It is where the next flight is prepared for. Rest is not nothing. Rest is the condition for everything else. Hummingbirds use visual landmarks to navigate. They learn the trees, the rooftops, the specific shape of the feeder against the fence, and they use these as reference points as they move through their territory. If you move a feeder even a meter or two from its original position, the hummingbird will often hover where the feeder used to be, confused for a moment before finding it in the new spot. The memory of the original location is so precise that it overrides the current visual evidence. The bird knows where it should be, not where it is. That is a kind of faith, in a way. A trust that the world will be where you expect it to be. In research settings, hummingbirds have demonstrated an ability to solve multi-step problems. One experiment involved a series of flowers that would only yield nectar if they were visited in a specific order. The hummingbirds learned the correct sequence and followed it reliably, even when the flowers were moved to new positions. The birds were tracking an abstract rule, not just a spatial location. If you visit blue, then red, then yellow, you get the nectar. The color sequence is what matters, not where those colors happen to be placed. A hummingbird worked that out. In a lab, by itself, in a few days. Hummingbirds can hear sounds in a higher frequency range than most birds. Their hearing extends into ultrasound, sounds beyond what humans can hear. This makes sense, given their world. At the frequencies and speeds at which they operate, finer-grained acoustic information is useful. They can hear the wing beats of rivals. They can hear the high-pitched alarm calls of other small birds. And they can hear, apparently, things we are not yet sure about. Because hummingbird hearing is still an active area of research, and every year brings new understanding. We have been watching these birds for centuries, and are still learning what they can do. The hummingbird has been itself for far longer than we have been watching. The hummingbird's relationship with humans has been, for the most part, a good one. In the modern era, setting aside the feather trade, hummingbirds have benefited from human proximity. Gardens provide flowers, feeders provide nectar, planted trees provide perches and shelter. Some hummingbird populations have actually expanded their ranges because of human activity. The Amaze hummingbird, as we mentioned, following gardens northward. Not all human-wildlife interactions end this way. But the hummingbird, adaptable and alert, has often found a way to make use of what people create. It moves into the space between wildness and garden, and it lives there as comfortably as anywhere. To attract hummingbirds to a garden, you do not need much. A feeder with sugar water, 1 part white sugar, 4 parts water, boiled and cooled, is enough to bring them. No red dye, no honey, which can harbor a fungus harmful to hummingbirds. No artificial sweeteners, which have no caloric value and leave the bird burning energy, without refueling. Just plain sugar water in a red feeder, cleaned every few days in warm weather to prevent fermentation. That is it. That simple act, a feeder in a window, sugar water in warm weather, has brought hummingbirds into the lives of millions of people who would otherwise never know them. And many of those people say it changed something. That having a hummingbird return to the same feeder every morning gave them something they are not always sure how to name. Connection, maybe. The sense that something wild and alive knows where you are. That you are part of someone's map. Even a very small 3-gram someone. There is a dignity in being recognized by something that could ignore you completely. The hummingbird does not need you, but it comes back. And that means something. In the high cloud forests of the Andes, where the air is perpetually misted and the trees are draped in moss, hummingbirds are everywhere. You cannot walk through certain forests in Ecuador or Colombia without encountering them every few minutes. A flash of green in the understory, a purple blur above the flowering canopy, a sudden hum from the bush beside your shoulder. These forests are some of the most biodiverse places on Earth, and the hummingbirds are woven through all of it, pollinating, competing, nesting, feeding, surviving. The cloud forest exists in a kind of permanent twilight, the mist blurring the sun, the trees filtering what light remains, and the hummingbirds navigate it with their 4-color receptors and their spatial memory and their impossible speed. I think about those forests sometimes and feel something like wonder that is also something like peace. The hummingbird's heart is the largest heart, relative to body size, of any warm-blooded animal. About 2.5% of its total body weight is heart. That large heart, pumping 1,200 times a minute in flight, is what makes everything else possible. Without it, the wings cannot beat. Without it, the eyes cannot see. Without it, the brain cannot plan. The heart, proportionally enormous, doing more work per unit of body than any other warm-blooded heart on Earth, is the center of everything. every other extraordinary thing about this bird is possible because of that one extraordinary pump, working without ceasing at its center. And in torpor, that heart, that impossibly fast, enormously hard-working heart, beats just 50 times per minute. 50. From 1200 to 50. In the same bird, in the same night. It lowers itself by more than 95%. And then, in the morning, it climbs back up again, without damage, without complaint, ready. This capacity, this vast range of function, is a kind of biological miracle, so quiet and so regular that it happens every night, and we barely think about it. Tonight, your heart is working too. Not at 1200 beats per minute, probably something between 60 and 80, maybe lower now than when you started listening. Your body is already doing what it knows how to do. It is finding its pace. It is settling toward the slower frequencies. You do not have to do anything. Your body is already on the way. The relationship between hummingbirds and their flowers is sometimes called mutualism. Both benefit. The bird gets nectar, fuel for its extraordinary life. The flower gets pollination, the chance to reproduce, to send its genes forward in time. Neither is exploiting the other. Neither is giving more than it can afford. It is a balanced exchange, millions of years in the making, refined by trial and error into something that simply works. There is something to admire in that. A relationship that sustains itself because it benefits both sides. A connection that holds because neither party takes too much. Some researchers study hummingbirds by placing high-speed cameras in gardens and forests, filming the birds at several thousand frames per second, and then slowing the footage down to understand what is actually happening. At normal speed, you see a blur and a hum. At high speed, you see something extraordinary. Each wingbeat is a complete and deliberate arc. The rotation of the joint, the flex of the primary feathers, the precise angle at which the wing meets the air. Nothing is sloppy. Nothing is wasted. Every millimeter of movement is exactly what it needs to be. The hummingbird is not rushing. At its own timescale, at 50 wingbeats per second, it is moving with complete control and grace. It is only from the outside, at our slower perception, that it seems blurred. This is a perspective worth sitting with. The blur is ours, not the bird's. The speed that we cannot pass is perfectly clear to the creature living it. What looks like chaos from a distance is often precision up close. And perhaps that is true of things in our own lives. Days that feel blurred and fast from the outside have their own internal clarity that is only visible from within. Hummingbirds have been observed bathing, not in bird baths. They do not typically land in water. They fly through it. They hover in rain, or in the spray of a garden hose or a fountain, letting the water bead on their feathers, then shaking it off in flight, the way a dog shakes after a swim. They fly through wet leaves, deliberately brushing against them, to wet the feathers, then finding a perch in the sun to preen and dry. They do this for the same reason all birds do. Feather maintenance is critical, and clean feathers perform better in flight. A hummingbird with dirty or damaged feathers is slower, less agile, less precisely controlled. Cleanliness for a hummingbird is not vanity. It is engineering. Speaking of feather maintenance, hummingbirds molt their feathers once a year. Molt is the process of replacing old, worn feathers with new ones, and it happens gradually. Not all at once, which would leave the bird unable to fly, but feather by feather, over several weeks or months. The gorget, the iridescent throat patch, is replaced during molt, and a male hummingbird during molt may look ragged and dull, his brilliant colors temporarily patchy and incomplete. But the new feathers grow in brighter. After molt, a male hummingbird's gorget is at its most vivid, deeper, more saturated, more fully itself than before. There is something in that too. The period of looking worn is followed by the period of looking most alive. Most hummingbirds are diurnal. They are active during the day and rest at night. But some researchers have observed hummingbirds feeding at dusk and occasionally even in low light conditions. Their eyes are adapted for their fast-moving, precise world. They have excellent temporal resolution, meaning they can detect movement very quickly. But in pure darkness, they are as helpless as any bird. The last feeding of the day is crucial. It is the filling of the tank before the long fast of night. Many hummingbirds can be seen feeding intensely, in the hour before sunset, moving faster and visiting more flowers than at any other time of day. They are getting ready, preparing for the stillness, loading up on everything they will need to survive the dark. Does that feel familiar? That urge before rest, to gather everything, to check everything, to make sure you are ready, before you can let go. The hummingbird does it at the flower level. You do it at the life level. And then, at some point, it is time to stop checking and let the evening arrive. The hummingbird, when it is finally ready, drops into torpor completely. No hesitation, no halfway, all the way in. That kind of surrender, the complete kind, is worth practicing. Hummingbirds have been found in some surprising places. In urban parks, on the tops of skyscrapers during migration, in suburban backyards in the middle of cities. During migration, they are guided by a magnetic sense, an ability to perceive the Earth's magnetic field and use it as a compass. This magnetic sense, combined with their visual landmark memory and their inherited directional instinct, allows them to navigate, across thousands of kilometers of unfamiliar territory, and arrive within meters of where they need to be. They do this without GPS, without maps, without anyone to follow. They read the Earth itself, its invisible lines of force, and follow those lines home. The Earth has a magnetic field that you cannot feel. It surrounds you right now, passing through the walls of wherever you are, passing through you, flowing from pole to pole in invisible currents. The hummingbird feels it. It is part of how the hummingbird knows which way to go. The world is full of forces we cannot perceive, but that are guiding things anyway. There is something quietly settling about that. Not everything visible is what's real. Not everything that guides us is something we can name. The broad-billed hummingbird is found in the mountains of Mexico and the very southwestern edge of the United States. Its beak is broad and slightly flattened, different from the narrow needle of most species. The male has a brilliant blue gorget that shifts to green in different light, and a bill that is red at the base and black at the tip. The broad-billed is one of those hummingbirds that stops people mid-sentence when it appears. You are talking about something, and then there is a hummingbird, and the talking stops. It is hard to finish a thought in the presence of something that iridescent. Maybe that is not a problem. Maybe some things are worth pausing for. The violet-crowned hummingbird has a white underside, unusual for a hummingbird, and a crown of deep violet blue that looks as though someone painted it on. The white-eared hummingbird has a stripe of white behind the eye, giving it a distinguished look, like a bird wearing reading glasses. The berylline hummingbird has rufous wings that flash warm copper in flight, a startling contrast to its green body. Every species has its own specific and particular beauty. Not generic bird beauty, but a specific combination of colors and shapes and proportions that belongs to that species and no other. They are individuals in their way, not interchangeable, each one itself. There is a hummingbird from Colombia called the lazuline sabruing. Its wings make a sound unlike any other hummingbird, a low, buzzing hum that is slightly lower in pitch than most, something closer to the sound of bees in a hive than the higher hum of a ruby-throated. Each species has its own hum, its own signature frequency. The wing shape, the wing area, the beat rate. All of these determine the tone. To a trained ear, you can identify a hummingbird species by the sound of its wings alone, even if you cannot see it. The garden has its own music, if you know how to listen for it. Research into hummingbird flight has directly influenced the design of aircraft and drones. Engineers studying hummingbird aerodynamics have learned things about lift generation, flow separation, and wing flexibility that could not have been easily discovered any other way. The hummingbird, in a sense, has been a teacher, nature has spent millions of years solving problems that engineers are only now beginning to understand. The study of biology to improve technology is called biomimetics, and the hummingbird is one of its most important subjects. Tiny drones that can hover in place and navigate through complex environments, search and rescue drones, environmental monitoring drones, owe something to the decades of study that began with people simply watching hummingbirds in gardens. Which means that the feeder in your backyard, the ruby-throated visitor every summer morning, is connected through a long chain of observation and curiosity and engineering to drones searching for survivors in rubble. Attention to the beautiful has practical consequences. Wonder is not impractical. It is often where the useful things begin. Hummingbirds can be parasitized. Small mites live in the nasal passages of some species, an unpleasant thought, and travel from flower to flower on the hummingbird's beak, using the bird as a taxi. These mites lay eggs in the flower, and the eggs develop there, then wait for the next hummingbird to arrive, and catch a ride to the next flower. The mites seem to do the hummingbird little harm in small numbers. They are passengers, not enemies. Tiny stowaways on the most improbable of transport systems. The world is full of these invisible relationships, these hitchhikers and passengers and accidental partnerships. Everything is connected to something else in ways that take a very long time to fully see. The sword-billed hummingbird, with its beak longer than its body, faces a unique challenge when it preens. Most birds preen by using the bill to work through the feathers. But the sword-billed's bill is so long that it cannot reach many parts of its own body with it. So it uses its feet instead, scratching and combing through the feathers with its claws. The evolutionary trade-off that gave it access to exclusive flowers also made certain ordinary bird tasks more difficult. No adaptation is perfect. Every advantage comes with its corresponding constraint. The beak that opens one door closes another. This is true in biology. It is true in other places too. The hummingbird has been thought about for a very long time by the people who shared its world. The Nahuatl word for hummingbird, the word used by the Aztecs, is Huitzil, from which comes the name of the god Huitzilopochtli, the deity of the sun and of war. The hummingbird was his symbol, a creature reborn with the sun each morning, blazing and fast and burning with energy. The Inca called it Siwa Quenti. In some Andean traditions, the hummingbird is a messenger between the human world and the world of the spirits. It moves too fast to see clearly and lives between the visible and the invisible. What was it that first suggested this to the people who watched them? Maybe the way a hummingbird vanishes and then reappears. The way it is there, and then not, and then there again, before you can fully account for the interval. In the Caribbean, The Taino people called the hummingbird colibri, a word that still exists in many languages as the name for the bird. In French, the hummingbird is still a colibri. In Spanish, it is often colibri. In Portuguese, beija-flor, which means kiss flower. The flower kisser. That is one of the gentlest names any creature has ever been given. A name that sees the relationship, not just the bird. A name that notices what the bird is doing and finds it tender. And it is tender in a way. The hummingbird approaches the flower with precision and care. It does not crash into the blossom. It does not tear or bruise it. It reaches in delicately, takes what is offered, leaves something behind, pollen on its feathers, life in the flower's future, and moves on. The transaction is careful. Nothing is wasted. Nothing is taken that is not offered. The flower is not damaged. The bird is not slowed. Both continue. Both are, in some small way, better for the meeting. The hummingbird's voice, when it does use it, is high and quick. A chip or a chatter, sometimes a buzzy warble. Researchers studying hummingbird vocalizations have found that the sounds are more complex than they appear. Males have song repertoires. They learn parts of their vocalizations. Not all, but parts, from other hummingbirds they encounter. This places hummingbirds in a select group of animals that are considered vocal learners. Animals that can learn new sounds and modify their vocalizations based on experience. Humans are in this group. Songbirds are parrots, elephants, cetaceans, and hummingbirds. The ability to learn and modify sound is a rare and remarkable trait, and a 3-gram bird from the Americas has it. Hummingbirds, it turns out, also experience something like play. Young hummingbirds have been observed doing flight maneuvers that serve no obvious function. No food to catch, no rival to chase, no mate to impress. They hover in one spot for long periods, then dart suddenly in a direction for no apparent reason, then return to hovering. This looks, to a careful observer, like practicing, like a young musician running scales, or a child testing how fast they can run, just to see. The young hummingbird, refining its extraordinary body through something that looks remarkably like joy. There are hummingbirds that live at the highest elevations of any bird in the Americas. The Andean hill star breeds at altitudes of up to 5,000 meters, nearly at the height of the summit of a very tall mountain. At 5,000 meters, the air is less than half as dense as at sea level. The oxygen is thin. The cold is severe. The flowers are few and far between. And yet the hill star lives there, feeds there, breeds there, goes into torpor each night to survive the freezing temperatures, then warms back up each morning and does it all again. There is almost nothing else alive at 5,000 meters that requires as much energy as a hummingbird does. And yet there it is, finding a way. This is perhaps the thing I find most worth sitting with on a quiet night like this one. The hummingbird is not suited to the conditions it lives in. The conditions it lives in are extreme: cold, high, thin-aired, flower-sparse. And it thrives there anyway, not by being immune to the difficulty, but by having a specific and elegant response to it. Torpor for the cold, extraordinary memory for the sparse flowers, proportionally enormous heart and brain for the thin air. The difficulty shaped the adaptation. The constraint became the design. Not despite the hard conditions, but through them, the Andean hill star became what it is. You are listening to this in your own particular set of conditions, your own climate, your own temperature, your own darkness. And your body, like the hummingbirds, has specific and elegant responses to all of it. Your breath slows in a warm room. Your muscles soften. Your heart rate settles. Your eyes close of their own accord. When the light is low enough, you are already adapted. You are already equipped. The conditions are right. Let the adaptation happen. Costa's hummingbird lives in the Sonoran and Mojave deserts of the American Southwest, one of the most arid environments where any hummingbird is found. It has adapted to the extreme heat and aridity by feeding in the early morning and late afternoon, resting in the shade during the heat of the day, and going into torpor at night to conserve energy. The male Costa's has a stunning purple gorget that extends outward on either side of his throat, like a purple handlebar mustache. During his display, he loops around the female in wide, high arcs, making a high-pitched whistle. In the flat, sun-bleached landscape of the desert, this purple blur looping through the air, above a creosote bush, is one of the more quietly extraordinary sights available. The desert is not what most people imagine as hummingbird habitat. It conjures the lush gardens of the east or the wet cloud forests of the Andes. But hummingbirds are more flexible than that. They live in deserts, in mountain meadows, in rainforests, in suburban gardens, in coastal scrub, in temperate forests. They have colonized almost every habitat in the Americas, where flowers grow and the temperature is survivable. The common thread is not the habitat. The common thread is the flower. Where there are flowers, there is the possibility of a hummingbird. And wherever a hummingbird is, something beautiful is probably about to happen. Hummingbirds sometimes get caught in spiderwebs. This happens more than you might expect. A bird moving fast through dense vegetation will sometimes fly straight into a web and become entangled. If the web is large and strong enough, it can trap the bird. This is distressing to witness, but it is also part of the world. What is interesting is that the hummingbird, also deliberately visit spider webs, not as prey, but for the silk. As mentioned, spider silk is an essential building material for the nest. The hummingbird lands carefully at the edge of a web, collects strands of silk on its beak and feet, and carries them back to the nest. The thing that can trap it is also the thing it needs. The resource and the danger come from the same source, which, now that I say it aloud, is not so unusual. Hummingbirds are indicators of ecosystem health. When hummingbird populations decline in an area, it often signals that the broader ecosystem is under stress. Habitat lost, flowers gone, climate shifted. Conservation biologists use hummingbird populations as one of several measures of how well a habitat is doing. A garden with hummingbirds is a garden doing something right. A forest with many hummingbird species is a forest with intact ecological relationships. The birds are not separate from the ecosystem. They are part of its functioning, a signal, in feathers, of how things are going. Climate change is affecting hummingbirds. Warmer springs are causing flowers to bloom earlier in some regions. Some hummingbirds, particularly those whose migration timing is set by day length rather than temperature, are arriving at breeding grounds after the flowers have already peaked. The alignment that took millions of years to build is shifting. Not broken yet, but bending. In other regions, warming temperatures are allowing some hummingbird species to expand their ranges northward. The rufous-tailed hummingbird, primarily a Mexican and Central American species, has been recorded farther north in Texas and New Mexico in recent years. New species in new places. Old relationships, newly strained. The hummingbird adjusts where it can. But adjustment has limits. And some of those limits are being approached. One quiet conservation story. In a mountainous region of Mexico, a cloud forest that once covered thousands of hectares was reduced by logging and agriculture to a few isolated fragments. The hummingbird species that depended on that forest declined sharply. But a group of local residents, farmers and school teachers and hotel owners, began a reforestation project. They planted native trees. They protected remaining habitat. They established small-scale ecotourism, focused on birdwatching. Over 2 decades, the forest fragments began to connect. The hummingbird population stabilized, and visitors came from Europe, from Japan, from North America, to stand in a mountain forest and watch birds that their parents would never have seen. A small group of people. A long period of patient work. A forest that came back. Birds that stayed. This is not a rare story. Versions of it happen all over the Americas. People who love a place and a creature and decide to do something about it. Not necessarily something dramatic. Sometimes just plant native flowers, put up a feeder, Leave that patch of garden a little wilder. Keep the cat inside. Put a decal on the window. The accumulation of small decisions by many ordinary people adds up to something. It adds up to a hummingbird on a Tuesday morning in June, hovering outside a kitchen window, its gorget catching the light, making that low, soft sound that is somewhere between music and machinery. The hummingbird does not know what you did for it. It does not know about the feeder you filled, or the flowers you planted, or the window film you put up to make the glass visible. It knows only that this is a good place, that there is nectar here, that it is safe, that this is worth returning to, and it will return. And that returning, that particular small loyalty, is something. It is not nothing to be a place that a hummingbird comes back to. Hummingbirds have survived for a very long time. They have survived the ice ages, retreating southward when the glaciers advanced, expanding northward when they retreated. They have survived mass changes in flora. When one group of flowering plants declined and was replaced by another, the hummingbirds shifted with it. They have survived the arrival of humans, the hunting, the collecting, the habitat change, and in many cases they have adapted. This does not mean they are invulnerable. 42 million years is not a guarantee. Some species are in serious decline. Some may not survive the century. But as a group, as a lineage, the hummingbird has so far proven itself remarkably good at continuing, at finding the next flower, at navigating the next obstacle, at surviving the night and waking in the morning, ready. Let's go somewhere quiet for a moment. Imagine a morning in a garden. Early. The light is just arriving. The dew is still on the grass and on the petals of the flowers. Everything is still. And then, from somewhere in the shrubs, from the sheltered branch where it spent the night, a hummingbird emerges. It is warming up from torpor. Its heart is climbing back to speed. Its wings flex once, twice, and then it rises. Silently at first, then with that low hum, into the morning air. It hovers for a moment at the edge of the garden, surveying. Then it moves toward the first flower. The day begins. Again, as it always has, as it always will. There is a gentleness in that image that I want to leave you with for a moment. The small bird, the morning light, the first flower, the world starting over in the simplest possible way. Everything that seemed complicated yesterday is briefly in that particular light. Just a garden, and a bird, and a flower. The hummingbird's relationship with time is one of the more interesting things to contemplate. Before sleep, it lives in a faster time than we do. Its heart beats 20 times faster. Its wings beat 60 times faster. Its reactions are faster. Its perception of movement is faster. In a very real sense, A hummingbird experiences more events per minute than we do. A minute of our time may feel like several minutes to the bird. This is why they seem so fast to us. We are slow by their standard. And yet, lifespan for lifespan, they do not live longer. More events per second, but fewer seconds. The total experience may not be so different from ours. Maybe. We cannot know. But it is worth wondering. Aristotle wrote about small birds and their intense vitality. He noticed that small animals tend to live fast and die young. Their metabolisms run hot, their hearts beat quickly, their lives are compressed. He wrote this over 2,000 years ago, before anyone had the tools to measure heartbeats or metabolic rates, or even to fully understand what metabolism meant. He was right. And the hummingbird is perhaps the most extreme expression of that principle in the entire animal kingdom. The most alive in terms of rate, the fastest heartbeat, the fastest wings, the fastest metabolism, the most intense expression per gram of living matter of what it means to be alive. And tonight, you are at the other end of that scale. Your heart is slowing. Your breath is long and low. Your metabolism is settling toward its minimum. You are approaching something like the hummingbird's torpor, not as extreme, but the same in kind. A surrender of the fast pace, a giving over to the slow, a trusting of the body to manage the night. And in the morning, like the hummingbird, you will warm up again. Your heart will return to speed. Your eyes will open. The day will begin again. And you will be ready for it, because you rested tonight. Completely. The way a small bird trusts the dark to hold it until morning. The fiery-throated hummingbird of Costa Rica has a throat that looks, in the right light, as though it is on fire. Orange and yellow and red, all at once, blazing. It lives in the high-altitude cloud forests of the Talamanca Range, where the days are cool and misted, and the birds are everywhere. To see a fiery-throated hummingbird in the right light is to see something that seems slightly too beautiful to be real. But it is real. It is more real, in some ways, than a lot of the things we spend our days worrying about. The bird is there. It has always been there. It does not know about worry. The purple-throated carib lives in the eastern Caribbean islands, Guadeloupe, Martinique, Dominica, St. Lucia. It is one of the few hummingbirds that shows clear differences in bill shape between males and females. The female has a longer, more curved beak. The male's is shorter and straighter. They feed on different flowers. The female on long, curved blooms. The male on more open flowers. By feeding on different flowers, They reduce competition between the sexes within the same territory. An elegant solution. Two birds sharing a home by occupying slightly different parts of the same world. The males and females of the same species have literally evolved different tools to coexist peacefully. Some hummingbird species have populations that live on islands and have become distinct from their mainland relatives over thousands of years of isolation. Island hummingbirds often have slightly different beak shapes, slightly different colors, slightly different behaviors. They have been shaped by their island, its specific flowers, its specific temperatures, its specific predators, into something a little different from what they started as. This is evolution in real time, stretched over thousands of years, but still visible, if you look carefully. The island changed the bird. As places always change, the things that live in them long enough. The green-breasted mango is a hummingbird of Central America and northern South America, also found occasionally in Texas. It is a large, robust hummingbird for a hummingbird, with a bold, curved beak and a rich green body. The male has a dark purple-black stripe down the center of his throat and chest, like a line drawn with a very fine brush. He perches prominently, calling from exposed branches, declaring his territory to the world. There is nothing subtle about the green-breasted mango. He is not a bird that tries to blend in. He has decided, it seems, that visibility is its own kind of protection. Be seen. Be bright. Be exactly what you are. The glittering-throated emerald sounds like something from a fairy tale, and in a way it is. It is a small, common hummingbird of lowland South America, common enough that it is often overlooked by birders chasing rarer species. But common does not mean ordinary. The glittering-throated emerald has a throat that, in the right light, seems to hold its own internal green fire. Not the fire of drama or spectacle. A softer fire, a glow. The kind of thing you only see if you slow down enough to look. Common birds reward patience. They always have. I want to talk about the moment when you first see a hummingbird. Not the first time in your life, though that is its own thing, but the first time on any given day. You might be standing at the kitchen window, or sitting on a porch, or walking through a garden, and then, without warning, there it is. The hum arrives before the bird does, often. That low, soft buzz resolves into a shape, and the shape resolves into a color, and for a moment, you stop whatever you were thinking. Not deliberately, not as a meditation practice, just because the bird is there, and it is enough to stop thought in its tracks. For a few seconds, you are just watching, just present, just here. That moment, the moment the hummingbird stops your thoughts, is a small gift. It does not last. The bird moves on, and the thoughts return. But for that moment, something very simple happened. You were entirely here, not somewhere else in your mind, not in the past or the future. Just in the garden, watching a small bird drink from a flower, listening to the hum. The hummingbird is very good at that, at pulling you into the present. Probably it is not trying to, but the effect is real. Some people keep journals of the hummingbirds they see. They note the dates of first spring arrival, the first ruby throat at the feeder on such and such a date in April. They note the last sighting of fall, the late rufous still coming to the feeder, in October, long after the others have left. Over years, these records become a kind of personal phenology, a map of the seasons, drawn not by temperature or daylight, but by the comings and goings of a small iridescent bird. When the hummingbird comes, summer is here. When it goes, something is ending. These small passages mark the year more meaningfully, for some people, than any calendar date. There are researchers who have devoted their lives to hummingbirds. Ornithologists who have spent decades in the field, in Ecuadorian cloud forests, in Colorado mountain meadows, in Mexican scrublands, studying one aspect or another of what hummingbirds do and how they do it. Ask any of them why they do it, and you tend to get variations of the same answer. Because there is always more to know. Because every question answered opens 3 more questions. Because the hummingbird, closely examined, yields an infinite interior. There is no bottom to what it is. The closer you look, the larger it becomes. This is true of most things in nature. The closer you look, the more there is. The hummingbird from a distance is a blur and a hum. Up close, in slow motion, it is an entire world, a system of decisions and memories and relationships and physical feats, so layered and so complex that thousands of hours of research have not exhausted it. And yet, and this is the part I find most settling, none of it is performed. None of it is for us. The hummingbird is doing what hummingbirds do, as they always have, regardless of whether anyone is watching. The world does not need our attention to be extraordinary. It just is. Quietly, always, it just is. There is a hummingbird species called the wire-crested thorntail. The male has a wire-thin crest of feathers that extends straight up from his forehead and a long, deeply forked tail that streams behind him like 2 thin ribbons as he flies. He is very small, a few grams at most, and he lives in the lowland forests of the Amazon basin and the Andean foothills. He feeds on small flowers and defends his patches with the standard hummingbird ferocity, his long tail streaming behind him as he dives at rivals. The name thorntail describes the sharp, spike-like tips of the outer tail feathers. Even the names, in hummingbirds, are specific. Wire-crested, thorntail, every word doing real work. The long-tailed sylph is perhaps one of the most extravagant-looking hummingbirds. The male has a tail of iridescent teal green that is twice the length of his body, long, trailing, shimmering as he flies. He lives in the cloud forests of the Andes, where the air is cool and the light is often diffuse and silver. In that soft light, his tail catches what little color there is and turns it to green fire. He looks, in flight, like a living brushstroke, something an artist applied quickly to a gray sky, and then changed their mind about and let the painting keep anyway. The white-necked Jacobin is found from Mexico south to Bolivia and Brazil. The male has a white belly and a white nape, a pale collar at the back of the neck that contrasts sharply with his deep blue head and green body. He is bold and conspicuous, perching in the open, easily visible. The female, by contrast, is speckled and green below, much more camouflaged, much more cautious. This difference in visibility reflects their different lives. He needs to be seen to attract mates, to declare territory. She needs to be invisible to protect the nest, to incubate in safety. Their colors tell you what their days are like. The amethyst-throated hummingbird lives in the pine oak forests of Mexico and Central America. Its throat, as the name promises, is a deep and shifting purple, not the blazing magenta of some gorgets, but something quieter and deeper, like the inside of a geode, a color that is cool and still and somehow restful. I find myself thinking about that color now, the amethyst throat in the pine forest, in the dappled light, in the cool mountain air. There is something very calming about it. A small patch of purple in a green world. The sparkling violeteer is common at the edges of Andean towns and gardens. One of the hummingbirds most likely to be seen by a traveler in Ecuador or Peru. It has violet ear patches that flare outward when it is alarmed or aggressive, and a glittering green body that shifts between emerald and teal, depending on the light. It is bold enough to come to feeders in the middle of a busy garden, not bothered by people nearby. Some people who have spent time in Andean towns describe the sparkling violeteer as a constant companion, always there, at the flowers outside the window or at the feeder on the balcony. A familiar green presence in an unfamiliar city. The comfortable thing, the constant thing, the small familiar beauty that does not change, even when everything else does. It is worth saying something about the experience of being near hummingbirds, not just watching them, but being close enough to feel the wind of their wings. Anyone who has held a hummingbird feeder in their hand and had a bird hover at it, inches from their fingers, knows what I mean. you can feel the air. Not just hear the hum, feel it as a tiny pressure on your skin. The displaced air from wings, beating 60 times per second, creates a real physical sensation. At close range, people describe it as a soft, rhythmic pulse, like a miniature heartbeat, landing gently on the back of your hand. That sensation is one of those things that is very hard to communicate to someone who has not experienced it. But if you have, you probably remember exactly where you were, and what the air smelled like, and how still you tried to hold yourself, so the bird would not leave. Hummingbirds can detect the sweetness of nectar almost instantly. They have taste receptors on and around the tongue that respond to sweetness, and they use this sensitivity to quickly assess whether a flower or feeder is worth the energy of visiting. A dilute nectar, too little sugar, will be abandoned quickly. A rich nectar brings the bird back again and again. This is why the sugar-to-water ratio matters. 1 part sugar to 4 parts water closely matches the average nectar concentration of the flowers hummingbirds prefer. The bird knows what it wants. It has been calibrating this preference for 42 million years. Your 1-to-4 mixture is landing in a very old and precise expectation. The hummingbird's kidneys work differently from those of most birds. Because they drink so much nectar, they consume enormous amounts of water. Their kidneys process this efficiently, producing large quantities of dilute urine to shed the excess water. During times when nectar is scarce, in drought, in early spring before flowers bloom, the kidneys shift, conserving water more carefully. The same bird, the same kidneys, the same body, responding to different conditions, with different strategies. The body adjusts. It always does, if you give it enough time and trust it enough to find its own way. The hummingbird's feet, though small and weak for walking, are strong enough for what they need to do. A hummingbird perching on a twig grips with a reflex that engages automatically. The same tendon lock that other birds use, so that even in torpor, even nearly unconscious, the grip holds. The sleeping bird does not fall from its branch. The grip is a reflex, not a conscious act. The body holds on, even when the mind has let go. That is a remarkably comforting design. You are held, even in sleep. Even when you are not trying. The grip takes care of itself. Research into hummingbird genetics has revealed something beautiful about how so many species arose. The Andes Mountains are a relatively young range. They began their rapid rise around 20 to 25 million years ago, and the process is still ongoing. As the mountains rose, they created new habitats, cloud forests, alpine meadows, high-altitude grasslands, each with its own set of flowers and its own ecological pressures. Hummingbirds moved into these new habitats. Populations became separated by mountain ridges, and deep valleys. Over generations, they evolved differently. New species emerged. The rise of the Andes was, in a very real sense, the engine of hummingbird diversity. The mountains went up, and new hummingbirds came into being. Geology and biology working together over millions of years to produce something as small and as bright as a hummingbird. The number of hummingbird species is still growing, in a sense. Not because new ones are evolving quickly. Evolution on that scale takes far more time. But because researchers continue to find populations that turn out to be distinct species, rather than subspecies. Advances in genetic analysis allow scientists to compare the DNA of hummingbirds from different populations and determine whether they have been separate long enough to be considered different species. The answer is sometimes yes. A population that looked like one species turns out to have been two separate species, all along, living side by side in the same forest, unrecognized. The world contains more kinds of beautiful things than we have yet learned to see. There is something gently hopeful in that. You are getting close to sleep now. I can feel it in the way I imagine you are listening, less precisely than before, more drifting. That is exactly right. Let the words become less about their meaning and more about their sound. Let them be something to float on, rather than something to follow. The hummingbird is still out there. Somewhere in the Americas, many hummingbirds are in torpor right now. Their hearts beating 50 times a minute. Their breath almost nothing. Their small bodies giving themselves completely to the dark and the cold and the quiet. They are trusting completely the way very few things can trust. And it works. It always works. The morning comes. The heart climbs back. The wings lift. The world continues. What a thing it is to be a creature that trusts the night so completely. What a thing it is to know all the way down in the body that the morning is coming. That warmth will return, that the heart will accelerate again, and the wings will move, and there will be flowers. The hummingbird does not lie awake worrying about tomorrow. It goes cold and still and trusting into the dark, and lets the biology handle the rest. You can do a version of that tonight. Not the same. You are not a bird, and your biology is different. But the principle holds. Let the thinking slow. Let the body take over. It knows what to do. It has always known. Take a breath now. A slow one. Let the air in, all the way to the bottom of your lungs. And let it out slowly. Let your shoulders drop if they have risen. Let your jaw unclench if it has held. Let your hands open. Just open. Nothing to hold tonight. Nothing to carry. Just this breath and the dark around you, and somewhere far away, a small bird on a branch, with its temperature dropping and its heart slowing towards something very like peace. Think about what you know now that you did not know at the start of tonight. The iridescence that is light, not pigment. The heart that beats 1,200 times a minute. And then, at night, 50. The nest built from spider silk that stretches as the babies grow. The tongue that moves 13 times per second. The beak that evolved to fit a single flower. The memory that tracks 1,000 flowers by time and space simultaneously. The Gulf of Mexico crossing, 900 kilometers. Alone, non-stop. The torpor that brings the bird back every morning, new again. The 42 million years. The flower kisser. The ancient, hovering, 3-gram miracle that has been doing all of this for longer than we can easily imagine. Let all of that settle now. Not as information, but as weight. Good weight. The kind that presses you gently into the mattress. The world is very old, and very large, and very full of things that have been quietly extraordinary, long before we came along, to notice them. That is a calming thought, when you let it be. You are part of a very long story. You did not start it, and you will not finish it. But tonight, you are in it, and that is enough. Close your eyes if you haven't already. Let the darkness be comfortable. It is just the dark. Nothing hidden. Nothing waiting. Just the ordinary dark that has always been here at the end of every day, since days began. The same dark that holds the hummingbird in its torpor. The same dark that has held every sleeping creature for as long as creatures have slept. A very patient dark. A generous one. One that has never, not once, failed to give way to morning. The hummingbird will wake. It always does. And you will wake. And the day will be there waiting, with its ordinary beauties. The light, the coffee, the smell of the morning air through a window. And if you are very lucky, or if you live somewhere in the Americas, and you have a garden with flowers, or a red feeder with sugar water outside the window, there might be a hummingbird, hovering, making its low, soft sound, drinking, alive, old, iridescent, doing what it has always done, in this particular patch of the morning world. For now, let yourself be still, the way the hummingbird is still on its branch. Let your breathing be slow. Let your heart find its resting pace. Let the thoughts that are still moving gradually slow and stop. They will be there tomorrow. They can wait. Everything that matters can wait until the morning. Even the hummingbird knows this. Even the hummingbird, with its speed and its urgency, and its enormous heart, even it knows when to stop, when to let the temperature drop, when to let the heartbeat slow, when to give the body completely to the night. The world is still. The garden is dark. The hummingbird is sleeping. And somewhere, in the silence just behind the silence, there is that hum, very faint, very far away, like the memory of something beautiful that visited today and will visit again tomorrow. Good night. Sleep well. The morning is already on its way.